Hello everyone, welcome to my YouTube channel. My name is Dilip Kumar. Here I am going to talk about a machine learning. So let me write here a machine learning. Machine learning has categorized into three types. The first one is supervised learning. The other one is unsupervised learning, and the last one is reinforcement learning. Reinforcement learning is a very big topic I'm not going to discuss right now, but what I would like to focus is on supervised learning and unsupervised learning, which is really important, and most of the business use cases will be falling in this category. So if I talk about unsupervised learning, it is further classified into two types. One is regression and the other one is a classification, right? Now, if I talk about unsupervised learning, it is further again categorized into two types. One is clustering and the other one is dimensionality reduction. Right. All right. So let me talk about a supervised machine learning. Just let me write here. Supervised machine learning. Suppose if I have a data set, let me just say that there is an age and there is a weight, right? If I have a data set like this, I just wanted to write some data here, saying that 24 years, probably like 72, 26, 70, 28, 81, 30, something, uh, 87, or maybe 21 and 82. Suppose if I have a data set, age and weight, right? So what I would like to do here is I just wanted to put derive some model here, saying that, like, I just have this hypothesis. So I just wanted to give an input parameter, and I wanted to predict weight here, which is output. Remember guys, there are two important features here. One is age and the other one is weight. So age is an independent feature. This is an independent feature because it doesn't depend on anything, right? Now weight is a dependent feature, right? Dependent feature because it depends on age. So this we can also call it as input, and this we can call it as output. And remember one thing, in any kind of a machine learning problem, there can be multiple inputs, right? There can be multiple independent features, but there can be only one dependent feature. Please remember this. There can be multiple multiple input features, but there will be only one dependent feature. Okay, suppose if I wanted to predict the age. Suppose somebody has given. Initially I just wanted to train this model, train this whole model, and then I just wanted to predict by giving the value of age. By giving the value of age, let us say something like a 25, which is not there in the data set. I just wanted to predict weight here. So this is a small this is a small explanation on supervised learning. I'd like to talk more in the coming sections. Now let me talk about regression problem. Okay, so regression problem. In regression, let me just take the same example what I've taken earlier, age and weight. So let me write here again. Let me just say that 27, 72.5, 26, 71, 23, some 74, 21, 76, some 28 and 77, right? Like, and much more data, and you have so much data below again. So let me just say this is the data set what I have. Now what I would like to do here is, you know, I just wanted to uh, plot a graph on the x-axis. On the x-axis it will be input is here age, right, and the output is which is dependent, which is called weight. Now I just wanted to use a scatter plot uh, to plot this data. I just wanted to use scatter plot. So I just found this data something like this. Okay, now what I actually wanted to do is I just wanted to put a line which is y is equal to mx plus c, where m is a slope and c is an intercept, right? So if I wanted to predict, if I wanted to predict the input, suppose if I wanted to predict an age which is 26 or 27, uh, maybe 25, let me just say, which is not there here. So then I can predict the data from here, saying that there will be some value in the weight. So this we can predict by using this regression line. So if I wanted to predict something on the input, I can just use this best fit line to predict the output, which is called a weight, right? This is just a hypothesis. This is actually like uh, this is just an hypothesis that we just wanted to predict. This is a prediction value, and these are the actual values. So based on this data, we would like to get the best fit line, which is called a linear regression, and from this linear regression, we uh, would like to predict the output, right? One more important thing I would like to mention here is in a regression problem, you will see that output is a continuous. So this is really, really important. How do you say that it is a regression problem? When you look at the output, this is a continuous, right? So with this, you can say this is a regression problem. You need to be very careful and you need to understand this is the most fundamental thing in regression. The output should be continuous. All right. Now, now let's talk about a classification problem. Classification. Let me just write one data set saying that number of study hours, and number of play hours, number of sleep hours, and my output here will be pass or fail, pass or fail, fail, pass. So I have a data set like this. I just don't want to write anything here, but just imagine some values there. So I have a data set here and saying that with this respective data, and saying that this is pass, with this respective data it is saying that it is false. So remember, if the output is having a fixed number of categories, then it is a classification problem, and if it is having two categories, then it is binary classification. If it is having more than two categories, maybe three or four, then it is called as multi classification problem. So you might be understanding the differences between regression and classification. In classification, the output is continuous, and sorry, in regression, the output is continuous. In classification, the output is discrete. That means there will be like fixed number of categories. either it is showing pass or fail here in this example. Right, now let's talk about unsupervised learning. Unsupervised learning. So in our earlier sections, we have discussed a little bit on unsupervised learning. Unsupervised learning categorized into two types. One is clustering, and the other one is dimensionality reduction, right? Dimensionality reduction. Now let me talk about a clustering here. Suppose if I have a data set, suppose let me just say that salary and age, if I have a data set like this, and I have a lot of data set here. Now here we don't have an output here. We just have a data set which is only independent data. There is no dependent variable here. So that is the main difference between supervised learning and unsupervised learning. In supervised learning, you will have both input and output, and based on the regression, you're going to, I mean, based on the type, basically like by training the model based on the input and output, by giving a new variable, you're going to predict the output. But here in unsupervised learning, you don't have output here. You don't have a dependent variable, you have only independent variables. But how can you do that clustering here? Suppose clustering means it is a kind of a grouping, right? Suppose you have your three clusters. In three clusters, I just wanted to group them in terms of age and in terms of salary. Suppose a person is having an age less than 25 years and he's having high income. So I just wanted to group this as a higher class. Okay. And if a person having an age who is having 25 years and having low income, let me just say, and if a person is having an age between 30 to 35, 30 to 35 and getting a salary between the average of between these two. So I'll just say this is categorized into middle class. So what I actually did is I just made this as a group so that based on the data set, I just wanted to make this as a group so that in future probably like I just wanted to sell a product. So I just wanted to target I just wanted to target the product which is very less, so that I can target lower salary people, which is having some medium range product. Then I can target middle class level people, which is having high end product. Then I can target the higher end class people. So likewise, I can just target based on the clusters. This is regarding the clustering of unsupervised learning. Now let us go further and learn about dimensionality reduction. In dimensionality reduction, what actually the name itself says that dimensional reduction, right? Suppose if you have uh, you might be having like 1,000 variables, right, in the data. You don't need all these 1,000 variable. You can make this reduction till 100 variables. So there are different kinds of techniques for doing dimensionality reduction. There are some algorithms called as principal component analysis, and there are some other algorithms I'm going to talk about in our further videos. So well, these are the main concepts in machine learning. In my further videos, I'll try to elaborate all these things in a detailed way. Until then, see you in the next one. Bye bye.